All right, hello everyone. Welcome back. Let's do this. 5, 2, 3. How else can I write the equation? Recursive sequences. Now, this is where we're starting to get a little deeper into these problems. Things can start getting a little trickier, so I really hope you're paying attention as you're watching this video, okay? In this chapter, you have been writing the equations for arithmetic sequences so that you could find the value of any term in a sequence, such as the 100th term directly. Today, you will investigate recursive sequences. A term in a recursive sequence depends on the terms before it, okay? So it's a different type of sequence than we did yesterday, okay? Or than we did today in class. This is called a recursive. A recursive sequence means a repetitive thing, something we do again and again, okay? Look at the following sequence. Please write this down. 571, please write these values here. -8, -2, 4, 10, etc. Okay? What are two ways that you can find the 10th term of the sequence, and what is the 10th term? So please pause the video and find the 10th term of the sequence. Two different ways. I want you to think of both of them, okay? All right, pause it and do it. Go. Okay, so hopefully you found the 10th term, okay? How did you do it? That is the big issue I want to come up with. Well, one of the things you could have done was what? You could have written an actual equation. So maybe you figured out the equation that it was, okay, it was going down by, or we're adding 6 every time. Technically, remember, we need to find term 0 in order to think of an equation, which would be -14. So maybe you were thinking, oh, 6x plus -14 or -14. So y equals 6x plus -14. And so you said, hey, you know what? If I do that, maybe I can find the equation, and that's it. Okay? Or maybe what a lot of people did is maybe you made a table and you said, hey, this is n, this is t of n, and so I've got term 1 is -8, term 2 is -2, term 3 is 4, then 4, 5, 6, 7, I'm gonna run out of room, 8, 9, 10, and so then you plugged in your values and said, oh, okay, we're adding 6 every time, so 10, 16, 22, 28, 34, 40, 44, woo! The 10th term is 44. Is that what you got? Okay, well, great. Now let's follow on to B. So the 10th term is 44. If you've not done so already, question B, write an equation that lets you find the value of any term. Now, T of n, this kind of equation is called an explicit. Explicit, okay? Now, explicit, a lot of you are familiar with that word more for the bad things. Explicit, like explicit lyrics. What that means is unedited, go straight to it, it's not blocked, it's directly to it, okay? Explicit. So it helps us plug in a value and get the exact answer, okay? Now, we kind of did that already because it follows very much the form of, since this is linear, it follows very much the form of y equals mx plus b. However, it does use kind of a combination of y equals mx plus b and f of x and t of n, right? Because it says of any term t of n. So therefore, I should be doing t of n equals, what do you do? Well, 6n minus 14. And that's what we're looking for. It really is our y equals mx plus b, just with different variables. Not f of x, not x and y, but t of n and n. So I'm going to plug in my term number, my term number there, and solve it, and it'll give me the value of that term. So, you know, using that, if I were going to solve this, I'm looking for the 10th term. So t of, and you don't have to write this, I'm just showing you, would be 6 times 10, the term number, minus 14. And so the t of 10, the value of 10, would be 16 minus 14. And when I do that, t of 10, oh, that seems interesting. I get 56. So the question is, where did I mess up? What did I do wrong that got me a different number than what it showed here? Anyone catch me on what happened here? 10. Oh, well, I did 2 mistakes. Holy cow, did anyone catch me on my 2 mistakes? See, as a teacher, I sometimes even get caught up in this. There were 2 mistakes. Did you catch them? Ooh, can you figure it out right now? Why this doesn't match up? I figured it out, it took me a minute. Well, the first mistake I made was right up here on the table. Everything was cool up until the last point when I just added 4. This should have been 46. Okay, 40 plus 6 is 46. And then my other problem was here, 60 minus 14 is 56. Yeah, I don't think so. It should be 46. Wow. Okay, strike 2. Man, that was horrible, guys. Sorry about that. Okay, so term 10 is 46. So as you see, that's the process. And basically, it's just using this explicit equation. An explicit equation gives me an exact answer with nothing else in between, nothing blotted out, nothing, just gives me the direct answer. Okay, now here's where it gets a little more complicated, so please focus. The next term after T of n, okay, so T of n is just, this is T of n, just this value right there, right? That's T of n in this particular case. The next term after it is T of n plus 1. Whoa, what's going on with that? T of n plus 1. Well, if T of n, let's say T of 1, right? T of 1, the term after it is T of 2, right? So this would give me the value which would be negative 8, right? And the value of the second term would be negative 2. But isn't 2 the same as saying T of 1 plus 1? Like if I take this term and add 1 to it, I get the next term, right? So yeah, T of n and T of n plus 1. All it's saying is if this were term 5, well, the next term would be term 6, right? And how do I find that? By doing 5 plus 1, okay? So that's kind of weird, but don't get overcomplicated with that, okay? The next term after T of n is called T of n plus 1. Write an equation to find T of n plus 1 if you know what T of n is. An equation that depends on knowing the other terms is called a recursive sequence. Okay, so we're looking for a recursive sequence, something that builds on something else, okay? So, here we go. Since I'm looking for T of n plus 1, that would say T of n plus 1 equals. T of n plus 1 equals. Well, what does it equal? If I want to find, let's suppose I didn't know what this number was right here. If I wanted to find what this value of this term was, what would I do? I would add 6 to this value. So I would find T of n, to get T of n plus 1, I would find T of n, and what would I do to it? I would add 6. That's it. T of n plus 1, to get the next term, I do the current term plus 6. Does that make sense? Okay? Cool, please write that down. That's called a recursive. Because for any of these, if I to get the next term in the sequence, what do? Just find the current term, add 6. To get the next term, I find the current term, add 6. And I just repeat this process of taking the current term, adding 6 to get the next term. All right, now, 572. Alejandro used the recursive equation, hey, T of n plus 1, looks familiar, equals T of n plus 6 from part C in problem 571 to write the following sequence. 0, 6, 12, 18, 24, okay? Please write that down, and please write this equation down. And tell me, is he correct? Does that work? Is T of n plus 1 equals T of n plus 6 in this equation? Or in the sequence? Well, yeah, it does, right? We're adding 6 to the previous term to get the next term. Does Alejandro's sequence match the sequence from problem 571? Does it match the sequence we were just using? No. So what's going on here? Question B, why did he get a different sequence than the one in problem 571? I mean, mathematically, both of them are correct, right? Look at this. To get the next term, I do the current term plus 6. So negative 8 plus 6 is negative 2, and negative 2 plus 6 is 4, and 4 plus 6 is 10, and so on. That's correct, but so is his. So how can you mathematically write down the information he needs so that he can write the correct sequence? If I wanted the sequence that I saw yesterday, I'm in the previous problem, so I want the t of n plus 1 equals t of n plus 6. I want that, but I want that to work only for this equation. Like I want to be able to tell you this is what you're going to do, and I want this right here. What else can I do? What else could I say? What could I do to convince someone to write mine and not the one up there? Well, to do that, I have to do one more step. I have to tell whoever's writing it where to start. Right? Doesn't that make sense? Like right here, they chose to start at 0. Why not start at 0? But if I tell them, hey, do this t of n plus 1 equals t of n plus 6, but I want t of 1, I want the first term to be -8. Now you know, oh, okay, the first term in my sequence is -8, and to get the next term, I take the current term plus 6, so the next number would be -2, and then +4, and so on and so forth. So for a recursive sequence, this is really important. Recursive sequence. You need two things. Number one, you need what to do to t of n. Okay, what to do to t of n, like adding 6. And then the second thing, write this down. You need first or 0 term. Like you need to tell what the first term or the 0 term, and we'll get to a little bit more on that later, but you need to tell them where to start, okay? If you do not include both parts, it does not work. Just including t of 1 equals -8, that doesn't tell me anything. And just in saying t of n plus 1 equals t of n plus 6 doesn't tell me anything either. So you need both parts to make this work, okay? All right, that is it for today. We will pick up where we left off with this tomorrow. So please make sure you're ready for that. Have a good day. We'll see you then.